Part 1 of Lesson 5, Chapter 2 is on rational functions. The word rational means it can be written in the form of a fraction. So here's your basic definition of a rational function. Every function that is a rational function can be written like this: f of x equals a of x over b of x, where a of x and b of x are both polynomial functions. Now typically when you have a rational function, you have both a vertical asymptote, as you can see in the picture on the left, as well as a horizontal asymptote, like you can see in the picture on the right. There are going to be a few slight changes to these, but this is what we'll start off with a basic understanding of a rational function as a vertical asymptote and a horizontal asymptote. So the first example simply says find the domain of each function and find the equations of the vertical and the horizontal asymptotes. So they give us an equation. You see I've got the graph right over here. And so our domain, remember, any time you have to find domain, you need to be concerned about getting a 0 in the bottom of the fraction. So as you can see here, our domain is all numbers except for 3. So if you put 3 into that function, you get a 0 in the bottom. And if you look at the graph, you got a vertical asymptote at 3. The range now, oh, we don't have to do the range, do we? Sorry. Vertical asymptote. Every vertical line is written x equals a number. This vertical line happens to be at x equals 3. And then with the horizontal asymptote, every horizontal line is written y equals a number. And you can see it happens to be at y equals 1. But a little bit more on that, I want you to look at the equation. And we have a first-degree polynomial in the numerator and a first-degree polynomial in the denominator. And if you look at the leading coefficients, they're both 1, right? So if you take 1, divide by 1, that would give you the horizontal asymptote of 1, like you can see on this problem. Another problem, the same directions. It says find the domain of each function and then the equations of the vertical and horizontal asymptotes. Now this one's a little bit different. As you can see on the graph, we don't have a vertical asymptote right here. And if we were to take the denominator, 4x squared plus 1, and set it equal to 0, what would we get for answers? We get the square root of a negative number, right? And so that's going to be an imaginary value. We'd actually get plus or minus 1/2 I. So if you get an imaginary value by setting the denominator equal to 0, there are no vertical asymptotes, and thus your domain is all real numbers. Vertical asymptote, we've got none. And horizontal asymptote, we have, you can see here, it's at 2. Y equals 2, horizontal line. Now again, look at the equation and look at the leading coefficients. We've got a second-degree polynomial on the top and a second-degree polynomial on the bottom. Take 8 and divide by 4, and that should give you a horizontal asymptote at 2. So you always divide those leading coefficients when the degree on the top and the bottom is the same, but it won't always be the same. So example 2 is slightly different. It says for each function determine any vertical and horizontal asymptotes, like we did in the last problem, and intercepts. So that's one more additional thing we need to find. Then graph the function and state its domain. So just a few more parts that we need to find. On this problem, you can see the domain is going to be all numbers except for -3, because if you put -3 into that function, you're going to get a 0 in the denominator, which means we've got a vertical asymptote at x equals -3, because that's the one value we can't put in. The horizontal asymptote is y equals, now you can see on the graph it's y equals 0. I want you to look at the equation. We have a first-degree polynomial on the bottom. We've got a constant on top. Therefore, the degrees are not the same. If the degree on the bottom is bigger than the degree on the top, then it's going to be at 0. Your horizontal asymptote will always be at 0 in that case, like you can see here. Now we also need to identify the intercepts. Okay, so you can see that it crosses the y-axis at 2. And then of course it doesn't cross the x-axis, so that's the only intercept that we have. Last example Same direction. For each function, determine any vertical and horizontal asymptotes and intercepts, and then graph the function and state its domain. Now, on this one, we take the denominator, and we'd want to factor it. So when we see it in a factored form, it's much easier to identify the domain. So now the domain is all numbers except for -2 and +1. So that would be my domain. Because if I put in -2, if I put in +1, I'd get 0 in the denominator. Thus, my vertical asymptote, we actually have 2 on this one. This is the first time we've got 2 vertical asymptotes. Now, this is what the graphing calculator, and a lot of graphing calculators don't put in the asymptotes, which is good because the asymptote is not part of the graph. But hopefully you can see where it's flattening out right here at -2, and then right here as well at +1. So we're going to write x equals -2 and x equals +1 for vertical asymptotes. For the horizontal asymptote, look at the degrees. Since the degrees are not the same, you got a first degree on the top, you got a second degree on the bottom, then it's going to be at y equals 0. And again, you can't see the horizontal asymptote on your graphing calculator, but hopefully you can see that it's flattening out right on the x-axis there at y equals 0. Intercepts. Well, this appears to be crossing the x and the y-axis both at 0, so it looks like we just have one intercept, and it is at 0, 0. So this is your introduction to rational functions. This is part 1 of lesson 5, chapter 2, and the homework problems you're going to be working on are 1 through 8 all, 9 through 13 odd, and number 17. This will be collected on Tuesday.